Hello everyone, thank you all for coming. 2 days ago I was at a meeting, the pitfalls of exploration and how to avoid them, that was held at the Royal Society. I've seen Sean here, I don't know if anyone else was also at that meeting, but it was very interesting. I just looked at some of the statistics of the people attending, and at that meeting there were 86 oil companies, 48 contractors and 19 people from government. And yet the oil companies were really presenting some of the difficulties which obviously are in the hands of the contractors. Here we are at the Finding Petroleum. They're enrolled to come to the meeting were 89 contractors and 15 oil companies. Somehow our messages are not getting to each other, and yet really we should be meeting in very even meetings whereby we can tell each other what's going on. And that's really what this talk is about, is trying to tell you what's going on with regard to formats. So if we just look at the beginning, you used to have these 21 track tapes, and they held about 20 megabytes of data, the initial ones. They were actually the most efficient thing there was in the industry. It was quite extraordinary. CGG had a company called Sercel, and GSI thought, well, we better have our own electronics company as well. So they formed a small electronics company that built the drives to run these things, way ahead of what IBM were doing at the time. In fact, 10 times more capacity on the tape and far more powerful as far as speed was concerned. So this company they formed, TI, got sold off. GSI got bought by Western. TI is now the third largest chip manufacturer in the world, third or fourth anyway. And it was very fortunate that they did something like this, because it made sure that everybody had an exchange format, because you were limited to the acquisition system that you could purchase. There were only 3 or 4 of them on the market. These days, we now have, you'll see on the left-hand side there, and I have another one in my bag, TS1140, 4 terabytes of data. And these are deployed, they're out in the marine world already. They sit in a robot that can house 2.5 exabytes of data. That's not a very small, horrible tape. That's 2,500 petabytes of data. And they are already in the industry. I know that Western Geco in Houston have a 2-bay robot. Tullow are using them as well. They have a 1-bay robot and so on. Extraordinarily enough, we're trying to write formats from 1975 onto the 4 terabyte tape still. Why? No wonder data management's in a bit of a pickle. So, the formats we had back at the beginning, and I'm going to leave you to read a fair bit of this, because I've only got a short period of time to present. So I'm trying to just highlight the difficulties, why the society is doing what it's doing, and I'm speaking very much from a personal point of view here, and I'm pretty certain most of my facts are correct. So this is what you had before. It was great. Then 7-track came along. Anyone could buy a computer, program it up, put their cables on it. So people made their formats actually quite hard to understand, because 7-track tape was just off-the-shelf commodity. And the reason they made their formats quite hard to understand was they didn't need to go and exchange them. And if they were tough to read, they kept the processing as well as the acquisition. There was no desire to have an exchange standard. 1975, the SEG was persuaded by the oil companies to do something about this. They formed the Technical Standard Committee. What people don't realise is not only SEG A, B and C were ratified at that time, so was SEG D. So anyone recording SEG D 0, in other words, the original format, onto these is trying to record 1975 technology standard onto a 4 terabyte tape, which to me is pretty crazy. And that's why the formats get revised. They get revised to try and help you and the technologies and making sure that we actually capture not only what you need for processing, but what the oil companies need to release to the regulatory bodies that require the data at the end of the day. Now, I know that doesn't happen in the USA, and it's often why there are such problems. So, for instance, at the moment in microseismic, a number of the companies are going off and they're using SEG2. Now, SEG2 is a self-defining format with a 2 gigabyte limit. Do you remember the old days of Unix, the pointers, 2 gigabyte limits? You really want to go back there, but that's what people are doing. And they're not being driven by anything to produce a standard, because in the USA it's not a requirement. You don't have the same regulations. It's very different in Europe, and a good example of it is Eric Toogood, who runs Discos and very senior in the MPD, has said that if you want to shoot Norwegian waters from this season onwards, you will be using SEG-D 3.0. Otherwise, you're not going to be allowed. He's not going to give you the license to do so. That's why Sercel have rushed out. That's why Western have rushed out. They're now recording it. Why SEG-D 3.0? Because at long last, you can put a unit of measure that you know what it is, because it's an energistics table that all of the different groups are using. You know where you are because it's going to be an OGP, position and transformation coordinate reference system, because that's what all the different people are using within the standards bodies. And you know the time, because basically after a lot of work, we're using the epoch timestamp from 6th of January 1981, which was a true atomic count, and you can have a -1 if you want to convert historic data. So you know where you are, what you're measuring when you were there. Good start. So people are starting to listen, and it really is silly to try and use basically 1975 technology today. Liken it to the fact that if you wanted to change your databases back to 1975 technology, you better go and buy some card indexes, and boy, you're going to need a lot of them. So, this is basically what all of the formats are based on, and that's a tape, because that's all we had in the beginning, and we've kept that pattern, we've kept a binary, so anybody who's a reasonable programmer, go to the SEG website, pick up the format diagrams and program it so you can read that data. It's completely open. Even commenting on the new work on SEG-Y2 is actually completely freely available. You can join the committee. You do not have to even be a member of the SEG. So the EPSIDIC header, that's always been a bit of an issue. It now could be either EPSIDIC or ASCII due to SEG-Y1. There's no actual requirement to put anything into it, but of course that's very bad practice and it should be checked, and you should always demand it in contracts. Certainly the oil companies should, and if they haven't, the contractors should be reasonable enough to actually put something in there. The binary header, it's basically the same as it always has been. And this is how you might see it laid out with the trace headers with it populated. So this would be SEG-Y1. And anyone who wants to know anything more about it, they could ask me. They could also ask Eleanor. She was very involved in the efforts, and I thank her very much for that. So SEG-Y1 came out in about 2000, very much the work of the PSGB. And it was great because it actually gave a way of people putting information into the trace headers that made it very easy to workstation load 3D data. Now, very few people flag the information as SEG-Y1 in the binary header, but it's become a de facto standard. So we've tried to maintain it with the new work on SEG-Y2, and that is the format that's on the table now. It's the format that will handle the microseismic, looking, the SEG-D 3.0 has been designed to handle seabed technology. All of these things, we go out, we spend a massive amount of time lobbying the industry, talking about what the new technologies are, making sure we get the major players into the meetings. So I'm just going to whisk through these as I say. But what we've tried to do with the changes is keep some downward compatibility, but to basically increase the dynamic range phenomenally, basically be able to support microsecond timestamps, look at a synchronization with SEG-D Rev 3, the backward compatibility with Rev 1, and so on and so forth. On tape and on disk, we've clarified how that should work. Historically, you could have variable traces written to disk, and that always confused a lot of people, and many people did not program correctly to cope with that, and so people used to go out of sync when you had random access data required for workstation loading. That's now been sorted out. If you're writing to disk, all traces will be the same length. Simple as that. And we tried to do the same with the rest of it. One of the big questions out there, though, is should it go big endian? SEG-D 3.1 will now allow big endian data. Historically, all the mainframe computers were little endian, and everyone, when they processed or read data, had to bit swap, basically, all the way through the data sets. With processing power, it never really was an issue, until recently. And Western G-Code reported back that with their new huge configurations and multi-component data, that it was actually having an effect on the processing and the subsetting of the data, sampling it, etc., and writing to tape. So now there's a series of big endian formats for SEG-D. Do you need the same in SEG-Y? Come and tell us. Coordinate reference system, we work very closely with the International Oil and Gas Producers Association. The SEG have gifted them the SEG-P formats, so all the positioning formats are now with the oil and gas producers. All the seismic sample ones are with the SEG, all of the data modelling, energistics. Very nicely, clearly defined. The binary header, and I'm just going to shoot through the rest of the slides in case you've got some other questions. But what you will notice on here is instead of things being highly recommended or not at all, they're now mandatory or your decision. Now from that, guidelines drop out. If it tells you it's mandatory, and you'll see in a number of fields that it is, you should be using them. We've even defined circumstances where the fields should be used. So there's no excuse now for not getting the information written correctly, and that should make everyone's lives easier. The other thing it does is it actually gives better access to new technology. I mean, who wants to have someone come along with some new fantastic surveying or acquisition method, and suddenly you've got data you can hardly read, so they have to then process it. So then you don't know really whether it's got the slant of that company on it or whether it's a truly independent picture. And you can't verify it because you can't read it anywhere else. And you're also giving a competitive advantage to your clients, because if they can read the data more efficiently, get the results more in advance of other people, they have an advantage. So using the formats runs right the way through the whole exercise. So, sorry, one of the things is we are, in the SEG-Y 2, is we're basically supplying standards for people, how they lay the header information out. These go in the episodic headers, which can be multiple headers, and this is the one for microseismic. So just whisking through the rest of it, the SEG has become involved with what's called a Standards Leadership Council. You'll see these are many of the people involved, not just with samples and positioning, but this is going on to pipe laying and things like that. Because what you don't want your pipe laying community to be using a different positioning standard to your rig. Otherwise, you're going to find your pipe over here and your rig's here, and that's very expensive. And so in with the rest of the bodies. We're trying to pull people together to appreciate and use each other's standards where it is appropriate. And what we'd like is some input from you. We're working with many of the governments around the world as regulatory bodies. We want input from contractors where new technology is coming along. We need you to look at these formats, and we're pushing to go for ratification of this format in September. So it's a short time frame. Please get involved. Please have a look at it. Thank you very much for your time.
Well done, Jill. And if you don't appreciate how important these standards are, just remember a few years back when we had to sometimes output ASCII from one package to input the ASCII to the next package because they didn't talk to each other in any other way. Anyway, a question, maybe one question for Jill? Bob Heath of iSize.
Thank you, Ian Jack, semi-retired. Jill, first of all, congratulations on an incredible amount of work. I don't think most people understand how much has been involved, but you haven't mentioned anything about non-standard formats. So could you say something about that, please?
Yes, many of the technologies, because of the expense, and unless an oil company is asking them, they'll just basically use whatever they've got software and they'll break the format. They'll do things it's not supposed to do. They'll have too many traces. They'll put floating point pointers in, floating point values into trace headers of SEG-Y when they're not allowed, so on and so forth. So basically, one of the things that Troika does as a company is we actually supply software to people to standardize those formats or actually correctly record the formats. But also our software actually sits in the front of the Promax size space processing system. So whenever you actually input data to that system, you call down a subset of our software for the I/O and the format handling. So on the fly, it'll standardize it, and you can actually populate the frameworks simultaneously from a whole group of tapes, giving you parallel input to the parallel processing, speeding the whole thing up. But that wouldn't have been necessary if people had actually read all the formats and done it correctly. But thank you.